For A, to work out the fraction of the initial energy lost, we have to do the fraction of the energy after divided by the energy before. So we'll just call those E2 and E1. Looking at the heights given of 2 meters and 1.6 meters, the balls are rest at these points, and so they have no kinetic energy. So we can therefore say at these points that the total energy of the ball is comprised completely of gravitational potential energy, which is shown by this equation. So we can just input this value into this. 2 will be 1.6. Right. These cancel out, and this gives you 4 over 5, which is the same as a 20% reduction. For part B, we want the speed of the ball before and after the bounce. So thinking of the first part here, we know that the potential energy is maximized at this point at the top, and as it drops, the potential is slowly converted into kinetic. And by the time it's at the bottom, just before it hits the floor, the potential is completely converted into kinetic. And so we can say that the potential energy at the top equals the kinetic at the bottom. So we can just equal this equation to this equation here. So mgh equals half mv squared. M's will cancel. We have 2gh equals v squared. So the velocity at the bottom equals square root of 2gh, where h is 2 meters. So when we input 2 meters in, we end up with a velocity of 6.3 for the bounce. After the bounce, we can just do the opposite of what we've done before. So we say that kinetic, the maximum kinetic from this point, turns into potential. So we can just say that the same thing again, but instead we input h as 1.6. And when we do that, we get 5.6 meters per second. For part C, there are a number of ways how the energy can be lost from the ball. If you look at this diagram, you can see how as the ball comes towards the ground, it actually compresses. And this compression actually heats the ball up because of the internal friction, which releases energy, of course. Energy is also lost through friction with the ground, and also the sound of the ball bouncing, of course, which will turn into heat energy.